All right, class, settle in, settle in. Today, we're going to pull back the curtain on something really exciting, machine learning. And look, we're not just going to talk about the theory. We're actually going to walk through the entire roadmap, how you build a model from scratch, from the very first question all the way to launching it. So let's dive right in. Okay, so before you even think about writing a single line of code, before you start looking at fancy algorithms, you have to start with the most fundamental question of all. Is AI even the right tool for what you're trying to do? You know, it's incredibly powerful for sure, but it's not some magic wand you can just wave at any old problem.
Let's break it down like this. Think about traditional programming. It is fantastic when you can spell out a really clear, precise set of if-then rules. You know, if a user clicks this button, then show this screen. It's perfect for problems you can define with pure logic. But what about problems where the rules are, well, they're kind of fuzzy, or maybe just way too complicated to write down? Imagine trying to write rules for translating Spanish to English. It's almost impossible. That is where AI really shines. It doesn't need you to give it the rules. It figures out the solution by learning directly from tons of data.
So you might be asking, how do I know if my problem is a good fit for AI? Well, the answer really lies in your data. It all comes down to the data. If you have a good amount of data that contains useful clues about the solution you're trying to find, then yeah, AI starts to look like a very, very promising path to take. All right, so you've decided AI is the right path. Awesome. Now we get to our first major phase. I want you to think about it like a chef getting their ingredients ready before they start cooking. For a machine learning engineer, those raw materials are ingredients. That's the data. So this whole data prep thing, it's a really careful three-step process. Step 1, we got to collect and clean our data. Step 2, we choose our features. Think of these as the clues our model is going to learn from. And then, the final step, we have to strategically split our data up for training and later on for testing.
Let me tell you, raw data from the real world is almost always messy. It's just a fact. So we have to clean it up. What does that mean? Well, it could be something like normalizing values. You know, making sure all the temperatures are in Celsius instead of a messy mix of Celsius and Fahrenheit. Or it could mean just getting rid of rows that are missing really critical information. The bottom line is, a clean data set is the foundation for any strong model. You can't build a good house on a shaky foundation.
Okay, next up, choosing your features. Now, this part is absolutely critical, and it's where you, the human expert, come in. You're going to look at all the columns in your data and decide which ones are the clues, we call those the input features, and which single column is the answer you want the model to learn how to predict. We call that the output feature. So, for example, a patient's medical history could be all of your inputs, and the output you want to predict is the chance they have a certain disease. And that brings us to the final, and I mean crucial, prep step, splitting the data. What we do is take our entire data set and we chop it up. The biggest piece, usually about 80% of it, that becomes our training data. This is the stuff the model gets to study. But the other 20%, we take that and we lock it away in a metaphorical vault. That's our test data, and it's super important we don't let the model peek at it until it's time for the final exam. Okay, our data is prepped, it's clean, it's split, it's ready to go. Now it's time for the main event, actually training the model. This is where the magic, the real learning, starts to happen. So, the very first thing you do in the training phase is pick your tool. And that tool is the machine learning algorithm. A good way to think about this is that algorithms are like different teaching methods, right? Some teaching styles are better for certain subjects than others. And you know what? If you're not totally sure which teaching method is going to work best for your particular data, a really great strategy is to just try a few of them out. See which one gets the best results. Experiment a little. And now, the training officially begins. The algorithm gets to work, and it starts sifting through all of that training data we gave it. It's looking, really searching for those hidden patterns that connect the clues to the answer. And I'll tell you, you gotta be patient here. This can take a while, especially if you have a huge data set. It's kind of like the model is going off to college for a semester. Or 4.
All right, so training is done. Our model has been studying hard. Now comes the moment of truth. We have to give it the final exam. It's time to find out how well our little student actually learned its lessons. Welcome, everyone, to Phase 3, Testing and Tuning.
And this right here, this brings us to what I would call the single most important, the golden rule of all machine learning. You absolutely must test your model using that test data we locked away in the vault earlier. No cheating. Why is this so important? Because that data is completely new to the model. It's the only true measure of how it's going to perform on information it has never ever seen before. I mean, that's the whole point, isn't it?
The goal isn't just to build a model that memorizes the answers from its study guide, the training data. We need to know that it can generalize. That's the key word. It has to have learned the underlying patterns so well that it can make accurate predictions on totally new problems out in the real world.
Okay, so what happens if your test results are, well, they're good, but they're not great? A lot of the time, we can make things better by tuning the algorithm's hyperparameters. Just think of these as all the little knobs and dials on the inside of the algorithm that control exactly how it learns.
And let me tell you, finding just the right settings for these knobs can make a massive difference in how well your model performs. It's usually a process of systematic trial and error. In fact, you can even write code that will automatically try out tons of different combinations of these settings to find the sweet spot, the best possible values for your specific problem.
So let's recap. We've trained our model, we've tested it, we've tuned it, and we're getting fantastic results on our test data. We're feeling good. Now it is time for the final phase, taking our model out of the classroom, out of the lab, and putting it to work in the real world.
But hold on. We don't just, flip a switch and push it out to everybody at once. No way. This final rollout is a really careful, phased process. First, we might test it with some live streaming data to see how it handles the real-time flow. Then, maybe we deploy it to just a small, select group of users, a little beta test. And only when we are absolutely confident that everything is working perfectly, then we release it into full production for the whole world to use.
And there you have it. The model is live, it's out in the world, doing its thing, making predictions. But this brings us to one last really important question. Is the job actually done? Think about it. The world is always changing, right? New data is being generated every single second. So is a machine learning model ever truly finished? That's a deep question, and it's one that every single machine learning engineer has to grapple with. Something to think about. Thanks so much for following along today.